In the vast silence of space, there are places where creation itself seems to pause and sculpt cathedrals of dust. They rise like ancient monuments, stretching for light years, their forms both fragile and eternal. These are the pillars of creation, vast columns of gas and shadow, standing in the heart of the Eagle Nebula. For centuries, humanity spoke of creation in myth and scripture. But here, in the quiet folds of interstellar space, the universe writes its own story of Genesis, stars igniting inside veils of darkness, light pushing against the weight of dust, and time carving shapes that resemble towers built by gods. They are hauntingly beautiful. Yet behind that beauty lies an incomprehensible truth. These pillars are not solid, but gossamer clouds, shaped by radiation, collapsing under gravity, and giving birth to suns that may one day host worlds. What appears serene is, in truth, a battlefield of forces beyond measure. For decades, the Hubble Space Telescope gave us glimpses of this cosmic wonder, capturing images that became icons of human curiosity. But Hubble saw only the surface, what light could pierce. Now, a new eye has opened, the James Webb Space Telescope. With its infrared vision, it strips away the veils, revealing what lay hidden. It shows not only the majesty of these pillars, but the violence, the turbulence, and the profound mystery within. And what it revealed was more than an image. It was a revelation of creation itself, caught in the act. In the spring of 1995, a transmission arrived from orbit that would forever alter the way humanity imagined creation. It was not the faint hum of a distant signal, nor the cryptic code of radio astronomy. It was an image, a single photograph, composed of light that had traveled for nearly 7,000 years before meeting the glass of a telescope orbiting Earth. The world would come to know it by a name both mythical and reverent: the Pillars of Creation, the Hubble Space Telescope. Barely 5 years old at the time, had already endured a trial by fire. Launched in 1990 amid great expectation, it carried the hopes of astronomers who dreamed of gazing deeper into the cosmos than ever before. Yet, its first images, blurred by a flaw in its mirror, were met with disappointment. Critics called it a failure, a billion-dollar embarrassment drifting uselessly in space. But science is patient. By 1993, astronauts aboard the shuttle Endeavour corrected its vision with a daring repair mission. For the first time, Hubble could see the universe as it was meant to. The images that followed began to reveal the cosmos in ways ground-based telescopes had never achieved. Swirling galaxies, delicate supernova remnants, faint quasars at the edge of time. Each photograph was a testament to the precision of human engineering and the restless curiosity of human thought. Yet among all these, one image would rise above the rest, not just as science, but as symbol. Astronomers at NASA's Space Telescope Science Institute directed Hubble's gaze toward a patch of sky in the constellation Serpens. It was not a region chosen for its brightness, but for its mystery. There lay the Eagle Nebula, or Messier 16, a vast cloud of gas and dust, more than 6,500 light-years away. This was a stellar nursery, a place where stars were not yet finished, where cosmic matter churned in silent turbulence, waiting for gravity to ignite its furnaces. The decision was deliberate. Hubble would look into the heart of creation itself, What it revealed was a sight no human eye had ever witnessed. Rising from the glowing gas of the nebula stood towering structures of shadow, vast columns of interstellar dust, each stretching several light-years in length. They appeared as monoliths, dark, cold silhouettes against a glowing backdrop, like the ruins of some ancient cathedral lost in the void. Their form was so eerily terrestrial, so reminiscent of towers and pillars, that language could not help but turn poetic. Scientists, often restrained in their descriptions, called them the pillars of creation. Yet this was no metaphor. The name carried truth. Inside these pillars, hidden by dense shrouds of dust, new stars were forming. Hubble's filters revealed faint glimmers, protostars cocooned in their embryonic chambers, nourished by collapsing clouds of gas. It was as if the telescope had torn open a curtain on the very process of Genesis, exposing the first breaths of suns that, for now, were only whispers of light. The cultural impact was immediate and overwhelming. Newspapers and magazines carried the image as though it were an artifact from another world. It was reproduced on classroom posters, museum walls, and the covers of books. The image did more than convey data-awakened imagination. For a public newly attuned to space exploration in the post-Apollo age, the pillars of creation became a symbol of the cosmic frontier, proof that science could reveal beauty equal to any art. But for astronomers, the image raised questions as profound as its beauty. Why had these fragile structures endured? They were formed of hydrogen and dust, materials so tenuous that one could not imagine them withstanding the relentless radiation of nearby stars. And yet there they stood, looming, intricate, sculpted by invisible forces. Were these pillars evidence of stability, or the remnants of something already dying? Were they nurseries of creation, or tombstones of destruction? The Eagle Nebula itself offered clues. Spanning nearly 70 light-years across, it was part of a larger cluster of young, hot stars, many of them only a few million years old. Their ultraviolet light bathed the nebula, stripping away gas and dust, sculpting cavities and edges. The pillars, scientists realized, were the stubborn remnants of denser material clouds resistant to erosion, like mountains standing against a storm. But within them, gravity continued its patient work, compressing gas into ever tighter knots, giving birth to new suns. The paradox deepened. These towers were both dying and creating, dissolving and gestating, eroding and igniting. To study them was to glimpse the duality of the universe, creation entwined with destruction, beginnings carved from endings. The light that painted Hubble's detectors carried the story not of a static monument, but of a dynamic battlefield of forces, radiation, gravity, turbulence locked in eternal interplay. Scientists began to estimate the density of the clouds, the temperature of the gases, the pressure exerted by surrounding radiation. They calculated that each fingertip of the pillar, those dense nodules glowing faintly at the ends, might contain hundreds of suns in embryonic form. These were evaporating gaseous globules, or EGGs, small clumps of gas destined either to collapse into stars or to dissipate into nothingness. Within those hidden cradles, stars like our sun, or perhaps greater, more massive, more violent, were forming in silence. Yet all of this was theory layered upon theory. The image itself was both map and mystery, a frozen instant of a process spanning millions of years. To the human eye, it looked eternal. But astronomers knew that what Hubble saw was already history. The light had traveled across millennia to reach us. The pillars, as they were, might no longer exist. Somewhere in that vast stretch of time, they could have already been eroded, shattered by the death throes of nearby massive stars. The first glimpse, then, was a paradox. Humanity was staring into the cradle of creation, but perhaps also into a graveyard of light years past. The image was not just a revelation of where stars are born, but a reminder of how fleeting such structures may be. In 1995, the world stood at the threshold of this revelation, gazing at a picture that was both scientific data and philosophical mirror. The pillars of creation were not merely a cosmic landmark. They were a question posed in silence across the abyss of space. How does creation endure within destruction? How do fragile forms survive amid chaos? And what does it mean that we, two creatures of dust and light, can look upon them and ask? The discovery was only a beginning. The questions it raised would echo for decades, leading astronomers to turn again and again to the Eagle Nebula. And though the image became an icon, it was never static. For science does not worship symbols. It pursues them, dissects them, and seeks the truths hidden within their shadows. The first glimpse of the pillars was not the end of a search. It was the opening act of a mystery still unfolding, one that would grow darker, deeper, and infinitely more profound as new eyes turned toward it. When the first image of the pillars of creation traveled down from orbit, the world gasped at their beauty. But in the quiet halls of observatories, among astronomers poring over the details, a different reaction took hold. It was not only aught with shock, for what they saw in those towers of shadow defied simple explanation. Rising for 5 light years into the nebular glow, they appeared as colossal monuments, massive and immovable, like the stone spires of Earth's own landscapes. They seemed to be carved with intention, their lines etched against the light like the buttresses of some ancient cathedral in the sky. To the human imagination, they looked solid, permanent, eternal. But the science behind them told another story, one far more unsettling. The pillars were not stone, nor even liquid, but clouds. Vast conglomerations of hydrogen gas, dust grains, and traces of heavier elements drifting in the interstellar medium. Their density was so low that if a cubic meter of the pillar's material could somehow be transported into a laboratory on Earth, it would be considered a near-perfect vacuum. These shapes that looked so impenetrable were, in truth, fragile veils, tenuous wisps bound together only by the competing forces of gravity and radiation. Here lay the paradox that startled scientists. How could something so delicate endure in an environment so hostile? The Eagle Nebula is not a place of quietude. It is alive with the ferocity of newborn stars, hot, massive suns that pour out ultraviolet radiation in quantities almost beyond comprehension. Each of these young giants is a furnace burning at tens of thousands of degrees, their light intense enough to rip electrons from atoms, their stellar winds blasting outward at supersonic speeds. Such radiation and pressure should scour the region clean, evaporating the dust, dispersing the gas, and leaving only the bright glare of stars. And yet, in the midst of this bombardment, the pillars remained. This survival seemed improbable. For decades, astronomers had studied the life cycle of nebulae, watching clouds collapse, ignite, and dissolve. Structures like the pillars should have been fleeting, quickly destroyed by the very stars they helped to birth. Their endurance, stretching for millions of years, suggested that processes were at work more complex than theory had allowed. Closer inspection of Hubble's image revealed hints of this struggle. At the tips of the pillars, tiny glowing nodules stood out, dense knots of gas called evaporating gaseous globules, or EGGs. Each was a potential star in formation, shielded by its own cocoon of dust. Surrounding them, the surfaces of the pillars glowed with ionized light, evidence of radiation striking their edges and burning them away. The pillars were not untouched. They were under siege. They were slowly evaporating too many. It was as if the universe had staged a cosmic paradox before our eyes, a structure simultaneously crumbling and creating, destruction and birth, written into the same vast form. The tension lay in their architecture. These were not chaotic wisps or random eddies of gas. They were towering forms, sculpted by pressure into something resembling terrestrial mountains, and yet wholly alien in their fragility. The ultraviolet light from massive stars outside the pillars acted like a sculptor's chisel, eating away at less dense material and leaving behind these denser spires. But how long could such structures last? Were we witnessing a monument still in the making, or ruins already collapsing? The questions multiplied. If the pillars were nurseries of stars, then inside them new suns would be gathering mass, collapsing under their own gravity, preparing to ignite nuclear fire. But if the pillars were being eroded by radiation, then their wombs might be torn open before those stars could ever form. Did these cosmic towers cradle life's beginnings, or did they doom it, erasing potential suns before they could shine? This duality unsettled scientists because it forced a reconsideration of the balance of forces in stellar nurseries. Gravity, the quiet architect of stars, pulls material inward, but radiation, the fierce product of stars already born, pushes outward, destroying what gravity tries to assemble. The pillars became the stage upon which this cosmic contest was frozen in light, a struggle between the urge to create and the inevitability of decay. The sheer scale of the structures only deepened the shock. 5 light-years is nearly 30 trillion miles. To the human mind, such distances are beyond comprehension. Yet, within those spans, the processes at play operate on timescales of millions of years. For us, the pillars seem eternal. For the universe, they are fleeting. Already, astronomers speculated that the light we saw might be deceiving us, delayed by distance. Perhaps the pillars had already been destroyed by a nearby supernova, and we were only witnessing their ghost, preserved in photons that began their journey long before human civilization learned to dream of space. The impossible architecture of the pillars was not impossible in the literal sense. It obeyed physics, but it stood at the very edge of understanding, where forces combined in ways so subtle and complex that they revealed the gaps in human knowledge. Computer models tried to simulate the interaction of gravity, radiation, and turbulence in star-forming regions. Yet no simulation matched the elegance of the real structures. Nature, it seemed, was still the greater artist. The philosophical weight of this realization was profound. To look at the pillars was to see a contradiction, a shape that appeared solid but was empty, that nurtured creation while collapsing, that existed in the present but might already be gone. It mirrored the paradoxes of human existence itself: fragility mistaken for strength, creation interwoven with mortality, beauty inseparable from transience. Scientists, by training, seek clarity. But here was a vision that demanded humility. The pillars of creation forced astronomers to accept that even the clearest image could conceal as much as it revealed, that behind every answer lay deeper mysteries, and that, perhaps, the greatest shock was not the pillars themselves, but the realization that the universe still held secrets so vast, so intricate, that human comprehension could only circle their edges in the end. The pillars did not just stun scientists with their form. They unsettled the very framework of understanding, forcing a recognition that the cosmos is not merely governed by simple rules applied in isolation, but by a symphony of forces: gravity, radiation, turbulence, magnetism woven together in ways still elusive to human theory. They were beautiful, yes, but their beauty was not passive. It was dangerous, violent, fragile. The impossible architecture of gas was a lesson that in the universe nothing is as it seems, and so the shock of discovery gave way to a deeper urgency. If these pillars were not monuments but moments, then time itself was the enemy of knowledge. To understand them, astronomers would need to look again, to gather more data, to peel away the illusions of dust and light. For the first glimpse had raised questions too large to ignore. The pillars of creation had become more than an image. They had become a riddle, one that science was now compelled to solve. The image from 1995 lingered in the public imagination, immortalized as a cosmic icon. Yet, for astronomers, it was never enough. Beauty was only the beginning. The pillars of creation had to be understood, dissected, unraveled through the steady discipline of science. And so, in the years that followed, the world's greatest observatories turned their instruments back to this haunting vista, determined to probe its depths. A decade later, Hubble returned. In 2005, armed with upgraded cameras, its vision sharper and its colors truer, the telescope captured the pillars once more. The new image was not merely repetition. It revealed subtleties unseen in the first, finer tendrils of dust, sharper outlines of erosion, faint glimmers of stars emerging at the edges. What had once seemed like shadow became intricately textured, like smoke twisting under an unseen wind. The towers looked less like monuments and more like battlegrounds, caught between creation and dissolution. But Hubble, despite its acuity, was still bound to visible light. Much of the story lay buried beneath the shroud of dust, hidden from optical eyes. To pierce those veils, astronomers turned to other instruments attuned to a different kind of light, each capable of peeling back another layer of truth. NASA's Spitzer Space Telescope, launched in 2003, observed in the infrared, where heat rather than brightness reveals the universe. When Spitzer gazed at the Eagle Nebula, the pillars transformed. The dark columns that had once stood silhouetted against glowing gas now dissolved into transparency. The shroud of dust, opaque to Hubble, became almost invisible. Within the murk, Spitzer uncovered what Hubble could not: the glowing embryos of stars. Protostars, still wrapped in their natal cocoons, flickered in the infrared, their warmth betraying them where visible light could not. The illusion of solidity was broken. What once appeared as vast monoliths now seemed fragile, half-vanished structures, their interiors riddled with collapsing knots of gas. It was as though Spitzer had shown us the skeleton beneath the skin, the inner life of the pillars themselves. Then came Chandra, NASA's X-ray observatory, which saw not in warmth or shadow, but in the high-energy violence of the cosmos. Through Chandra's eyes, the pillars were almost unrecognizable. The dust itself disappeared. In its place shone the blazing points of massive young stars. Many were hot O-type giants, luminous in X-rays, their radiation scouring the nebula, tearing at the very clouds that had birthed them. The juxtaposition was stark. The fragile cocoons of new stars nestled inside the pillars, and the fierce glare of older, massive suns outside, already dismantling their own nursery. Creation and destruction, side by side, visible in different wavelengths of light, together. These observatories painted a picture that was richer and stranger than the first glimpse had ever suggested. Inside the pillars, jets of gas shot outward from young protostars, carving channels through the dust. Shock waves rippled across their surfaces, evidence of turbulence stirred by radiation and stellar winds. Here was the hidden violence of birth, the turbulence of matter collapsing and exploding, a process that on human scales would seem cataclysmic, but in cosmic time was routine. Yet with these revelations came a deeper unease. Observations hinted that the pillars might not be as eternal as the iconic image had implied. Astronomers studying the Eagle Nebula detected signs of disruption far beyond the pillars themselves. A massive supernova, perhaps 6,000 years ago, may have sent shock waves racing through the region. If so, the blast could already have shredded the fragile towers, dispersing them into the void. This realization carried with it a haunting implication. The pillars of creation, as captured by Hubble and Spitzer, might already be gone. The beauty preserved in those images could be nothing more than a memory, a light echo from a structure erased in reality. Here the concept of astronomical time delay pressed itself upon the human imagination. The light that reaches Earth from the Eagle Nebula began its journey more than 6.5 millennia ago, long before the pyramids rose in Egypt, before cities were carved from stone, before human civilization took its first steps into history. To look at the pillars is to look backward, not into the present, but into an ancient past, frozen in the moment when those photons escaped their dust-bound prison and began the long voyage to us. This truth unsettled as much as it enlightened, for it means that astronomy is always an act of memory. The universe we see is never the universe as it is, but only as it was. Every photograph, every dataset is a postcard sent across the abyss of time. Its subject, perhaps, already changed or vanished. The pillars of creation became, in this sense, not just a site of scientific wonder, but a meditation on impermanence. Still, astronomers pressed on. They mapped the density of the gas, measuring how much matter might collapse into stars before the structures were lost. They traced the jets of protostars, estimating their mass and age. They studied the erosion at the edges, calculating how long the pillars might survive against the relentless assault of radiation. Estimates varied, but the consensus emerged. The pillars may endure for only a few 100,000 years more, a blink in cosmic time, and yet, in that brief window, they serve as both cradle and crucible. They shelter the fragile beginnings of new suns while crumbling beneath the light of older ones. They are the very embodiment of stellar ecology, where death feeds life, and life is forged in the ashes of destruction. Through New Eyes Hubble's sharp gaze, Spitzer's infrared clarity, Chandra's X-ray revelations, the pillars ceased to be silent icons. They became dynamic, restless, impermanent. Their majesty was no longer in their stillness, but in their motion, in the story of change written across their vast forms. For humanity, these discoveries deepened the paradox of beauty. What we cherish as timeless is, in truth, fleeting. The very structures that inspire awe are dissolving even as we behold them. Their image endures, but their reality may already be erased. The pillars of creation remind us that the cosmos is not a gallery of eternal forms, but a theater of constant transformation. And perhaps that is the greater wonder, not that such monuments exist, but that we were here to see them in this brief moment when light, time, and consciousness converged. The investigations did not end there. Each revelation only sharpened the questions. If the pillars are transient, what do they reveal about the cycle of stars across the galaxy? If their light is a message from the past, what is happening to them now, unseen, beyond the reach of current instruments? The mystery deepened, pulling astronomers toward the next chapter of exploration. For as breathtaking as the first glimpses were, and as profound as the discoveries of Hubble, Spitzer and Chandra had been, an even greater unveiling awaited. A telescope built not just to look deeper, but to look through, to pierce the dust entirely, and reveal creation in its rawest form. The James Webb Space Telescope was about to turn its golden eye toward the pillars, and what it saw would change the story again. In July of 2022, humanity opened a new window to the universe. The James Webb Space Telescope, stationed 1,000,000 miles from Earth, unfolded its golden mirrors and turned its gaze upon the cosmos. Its first images revealed galaxies stretching back to the dawn of time, starlight redshifted by billions of years, and structures so faint they had never been glimpsed before. But when Webb directed its attention to the Eagle Nebula toward the haunting towers known as the Pillars of Creation, it was not merely discovery, it was revelation for the first time. The shrouds of dust that had cloaked these columns for centuries in human sight were pierced with almost surgical precision. Webb's infrared vision stripped away the veil. What appeared opaque to Hubble was now translucent, transformed into intricate webs of glowing gas, lattice of turbulence, and countless points of starlight. Where once there had been shadow, there was now radiance. Where once there had been mystery, there was now a deeper, more intimate mystery still. The image stunned the world. Across the pillars, shimmering newborn stars shone in exquisite clarity, each one a sun in the making, cocooned inside cradles of gas. They glowed like embers caught in a cosmic wind, scattered throughout the columns, their presence far more numerous than astronomers had ever expected. Hubble had hinted at hidden stars, but Webb laid them bare mapping their locations with a precision that transformed a symbol of creation into a laboratory of star birth. The detail was extraordinary. Intricate tendrils of gas traced patterns along the surfaces of the pillars, delicate as lace, yet sculpted by forces of unimaginable violence. Each tendril was a record of shock waves and stellar winds carving through the dust, shaping filaments and ridges like rivers etching a canyon. At the tips of the pillars, those iconic finger-like extensions Webb revealed dense knots glowing with infrared heat. These were collapsing cores, the raw beginnings of stars so young they had not yet ignited nuclear fusion. The pillars no longer seemed like monoliths. They appeared instead as living structures, fragile, dynamic, restless. The very dust that gave them shape was also dissolving, churned by turbulence and stripped away by radiation. Webb's data painted them not as statues in stillness, but as storms in motion. Astronomers gasped not only at the clarity of the image, but at what it implied. There were far more stars forming than theory had predicted. For decades, models had struggled to explain how many stars could be born in such regions before radiation halted the process. Webb revealed that the process was richer, more chaotic, and more fertile than once believed. The pillars were not a quiet nursery. They were a crowded, bustling city of stars, with new suns emerging in every hidden alcove. But there was another side to the revelation, one that carried a sense of violence and impermanence. The very structures that sheltered these young stars were being torn apart by the light of older ones. Webb's spectroscopic instruments traced shock waves rippling across the surfaces. Evidence of gas-heated, collapsing cores lay side by side with evaporating clouds. Embryonic suns rose amid the ashes of dust destroyed. Birth and death, inseparable, woven together in the same frame. In the maps of turbulence, astronomers could see the fingerprints of destruction. Some regions glowed with the infrared signature of dust grains shattering under radiation. Others bore the faint mark of molecules, carbon monoxide, hydrogen streaming away into space, carried by stellar winds. To peer into the pillars with Webb was to witness creation not as a serene process, but as a tempest, violent and unrelenting. This was escalation in the truest sense. The mystery did not shrink under Webb's golden gaze, it deepened. The telescope had not solved the paradox of the pillars. It had sharpened it. How could such fragile forms endure in such a crucible? Were the stars within destined to survive, or would their cradles be torn open too soon? Scientists began to ask a more profound question. Is creation in the cosmos always inseparable from destruction? The answer seemed to emerge from the pillars themselves. The radiation of dying stars sculpted the clouds into new forms, compressing some regions even as it eroded others. Shock waves from past supernova triggered the collapse of gas into every act of devastation became, in some hidden way, an act of renewal. The cycle was not linear, but intertwined, as though the universe itself required endings to weave beginnings. Philosophically, this realization resonated with a kind of cosmic fatalism. The pillars of creation were not unique in their violence. Across the galaxy, in every star-forming nebula, the same pattern unfolded. Death feeding life, collapse fueling birth. Even our own sun was born from such a process. Its cradle likely ignited by the explosion of a nearby giant. The Earth itself, and all life upon it, is thus descended from a lineage of destruction. Webb's revelations made the pillars into a mirror. Humanity could see in them the inevitability of cycles that govern both stars and civilizations. Nothing persists unchanged. What appears stable is only temporary. What is born carries within it the seeds of its own dissolution. Yet, from that dissolution arises the next generation of light in the technical details. Webb's instruments provided unprecedented insights. The near-infrared camera, UNIRCam, detected protostars glowing deep inside the dust, their heat signatures mapped with precision. The mid-infrared instrument, MIRI, revealed cooler structures, dust grains, and organic molecules, illuminating the chemical complexity of the nebula. Spectroscopy identified elements scattered throughout, hydrogen fueling the collapse, oxygen and sulfur glowing at the edges where gas was ionized by ultraviolet radiation. These were not abstract data points. They were threads in the tapestry of stellar evolution. Each spectrum traced the story of matter cycling from old stars into new. Each glowing knot marked a moment in the timeline of suns yet unborn. Together they told a story not of permanence, but of motion, of constant transformation. The Webb revelation forced astronomers to reconsider the very metaphor of the pillars. For decades, they had been spoken of as monument spillers standing against the void. Now, they appeared not as monuments, but as participants in a dance, fleeting forms in a larger choreography of creation. Their shapes were incidental, transient, the temporary scaffolding of processes that would soon erase them. And yet, perhaps that was the true wonder. The universe had allowed humanity, in its brief existence, to witness this fleeting spectacle, towers of dust, at the exact moment they both sheltered stars and dissolved around them. To capture such a moment was an accident of cosmic timing, a gift of light delayed by millennia, but arriving now, when eyes were finally capable of seeing. The escalation of mystery was not just scientific, it was existential. If creation and destruction are inseparable in the cosmos, what does that mean for us? Are we, too, products of the same cycle born of ancient deaths, destined to pass our substance into futures we cannot imagine? The pillars, in their fragile majesty, whispered yes. The James Webb Space Telescope did not diminish the beauty of the pillars of creation. It magnified it, but also transformed it. No longer were they only icons of creation. They became symbols of impermanence, reminders that every birth is shadowed by decay, that every star carries within it both the promise of light and the certainty of death. Yet, in this paradox lies hope. For the ashes of one generation seed the next. The cosmos wastes nothing. Even destruction is creation in another form. And in the shimmering newborn stars revealed by Webb, humanity could see not only the future of the Eagle Nebula, but the echo of its own past, the same process that once kindled the sun, the same cycle that once set the stage for life. The Webb revelation was not the end of the story. It was a deepening of it, a reminder that the universe is not made of monuments, but of movements, not of permanence, but of change. And within that change, a beauty so profound that even in destruction there is awe. The pillars stand, for now, as both cradle and pod. They are proof that in the universe, creation is never clean, never separate from chaos. It is always violent, always fragile, always fleeting, and perhaps that is why it is beautiful. The James Webb Space Telescope did more than unveil hidden stars within the pillars of creation. It sharpened a question that has haunted astronomers since Hubble first revealed them in 1995. Why do these colossal towers exist at all? They are not solid, not permanent, not carved in stone. They are tenuous clouds of gas and dust, sculpted into cathedral-like forms by processes both violent and delicate. To explain them is to trace the competing forces of the cosmos itself, the push of radiation, the pull of gravity, the shockwaves of death, and the recycling of matter across eons. The pillars are not accidents. They are consequences, written in light and shadow. The most immediate answer lies in radiation. The Eagle Nebula, where the pillars stand, is crowded with young, massive stars. These suns, many dozens of times heavier than our own, emit ultraviolet light so intense that it ionizes hydrogen, stripping electrons from atoms and filling the nebula with glowing plasma. Their stellar winds rivers of charged particles, hurled outward at millions of kilometers per hour, blast into the surrounding gas. When this radiation strikes a cloud, it does not erode it evenly. Less dense regions are quickly swept away, like mist burned off by morning sunlight. But denser knots resist. They shield the material behind them, casting long shadows into the nebula. Over thousands of years, these shadows lengthen, forming towering columns of protected gas, while the surrounding material vanishes. What remains is what we call the pillars of creation sculptures, carved not by intention, but by erosion. This process, known as photoevaporation, is both creative and destructive. It strips gas from the surfaces of the pillars, heating and dispersing it into the void. But it also compresses material within the denser core, triggering collapse. Radiation sculpts the forms, even as it seeds their eventual demise. It is a paradox that defines the pillars themselves. Their very shape is evidence of a process that is destroying them. They exist because they are being eroded, yet radiation alone cannot explain their endurance. If erosion were the only force at play, the pillars would vanish quickly, shredded in the glare of their massive neighbors. Something else resists something quiet, patient, and inexorable. Gravity. Gravity works in opposition to radiation. Where radiation pushes outward, gravity pulls inward, gathering gas into tighter knots. It is gravity that allows dense clumps to resist erosion, and gravity that ignites stars in their cores. But the balance is delicate. If gravity is too weak, the cloud disperses into emptiness. If gravity is too strong, the collapse is violent, consuming the pillar too quickly. The pillars of creation exist in this fragile equilibrium, where the push and pull of forces sculpt structures that are neither fully stable nor entirely ephemeral. This balance may be fleeting. Astronomers estimate that such formations last only a few 100,000 years before being erased. Yet, in that window, gravity and radiation weave an architecture of astonishing beauty. The pillars are frozen witnesses to a contest that defines the cosmos itself. Everywhere in the galaxy, clouds of gas collapse into stars, and stars radiate outward to unmake the very clouds that birthed them. The pillars are not unique in this. They are simply the most visible, the most iconic, the most hauntingly sculpted into shapes that evoke permanence where none exists. But the story is not only of radiation and gravity. There is another hand shaping the pillars, the shock waves of dying stars. Massive stars live fast and die young. Within a few million years, an instant on cosmic scales, they exhaust their fuel and collapse, detonating as supernova. The blast waves from these explosions ripple outward, compressing gas as they travel. In regions like the Eagle Nebula, these shock waves trigger new rounds of star formation, squeezing clouds until gravity takes over. The pillars may themselves be the children of such an event. Long before Hubble captured their image, a massive star may have died nearby, sending shock waves that sculpted the nebula into new shapes. The very stars now eroding the pillars may have been born from a previous generation's death. This cycle is endless. Destruction fertilizes creation. The ashes of one star become the soil for another. The Eagle Nebula is thus not only a nursery, but a graveyard, a place where past and future intertwine. The pillars of creation are monuments to this cycle, carved by death, cradling birth. At the heart of this cycle lies cosmic recycling. The material forming the pillars is not new. It is ancient, forged in the cores of stars long vanished. Hydrogen and helium born in the Big Bang make up most of their mass. But sprinkled within are heavier elements: carbon, oxygen, sulfur, silicon. These were created in stellar furnaces, fused in nuclear fire, and scattered into space by explosions. Every dust grain within the pillars is thus a relic of stellar death. Tiny flecks of silicates, carbon compounds, and ices drift together, gathering into clumps. Over millions of years, these grains collect gas, forming clouds that collapse again into stars. The cycle repeats endlessly across the galaxy. Cosmic recycling is not abstract. It is personal. The same process that built the pillars also built us. The carbon in human cells, the oxygen we breathe, the iron in our blood, are forged in stars and scattered into the interstellar medium before coalescing into the sun and earth. The pillars of creation are not only images of distant phenomena, they are mirrors of our own origin, reminders that life itself is written in the ashes of stars. For all their majesty, the pillars are temporary. Their beauty is an illusion of timing, a fleeting form caught in light, delayed by distance. Astronomers estimate that the pillars may already have been destroyed by a supernova thousands of years ago. The light that reached us in 1995, in 2005, in 2022, may be nothing more than an echo of a vanished structure. This realization is unsettling. The image that hangs in classrooms and museums, that inspires wonder in millions, may depict something that no longer exists. Yet perhaps that is what makes it profound. The pillars are beautiful, not because they endure, but because they are ephemeral. They remind us that even in the cosmos, permanence is illusion. Everything is change, speculatively. Some astronomers suggest that all such formations are transient, destined to vanish as quickly as they arise. What we call the pillars of creation may simply be a momentary shape in the endless turbulence of interstellar clouds. To the universe, they are ordinary. To us, they are extraordinary because we were here to see them. In this brief intersection of light, time, and consciousness, what then do the pillars tell us? That creation is fleeting, that destruction is inevitable, that beauty itself is carved from impermanence. The pillars embody a truth written across the cosmos. Creation is not separate from destruction, but born from it. Stars form in clouds that are simultaneously being torn apart. Life emerges from matter that was once scattered by death. Even galaxies collide and merge, their violence seeding new generations of stars. For humanity, this is both humbling and consoling. Our lives are fleeting, our civilizations transient. Yet the pattern that governs us is the same that governs the stars. We are part of the same cycle, born of ashes, destined to return to them, and in that return, to become part of something new. The pillars of creation are not monuments of eternity. They are emblems of change. They remind us that permanence is not the measure of beauty. Fleeting things can be beautiful too, perhaps, more so because they are fragile, because they will not last. Theories explain the pillars as sculpted by radiation, sustained by gravity, triggered by shock waves, and assembled from recycled stardust. Speculation sees them as transient illusions, destined to vanish. Yet, beyond science, they hold a meaning deeper still. They exist because destruction creates. They exist because matter recycles. They exist because the universe is not static, but restless, ceaselessly sculpting and erasing, never satisfied with stillness. They exist because we are here to witness them, to receive their ancient light, to marvel at structures that remind us of temples and mountains, though they are nothing more than dust, and perhaps they exist to remind us of ourselves, that our lives, too, are fragile, that our civilizations, too, are fleeting, that our beauty lies not in permanence, but in change. The pillars of creation stand not as answers, but as questions. They ask, why does the universe create? Why does it destroy? Why does it allow us, creatures of dust and thought, to look upon its fleeting monuments and call them beautiful? Theories and speculations offer partial answers, but the deeper truth may be that their meaning lies not in their physics, but in their impermanence, that to exist, even briefly, is wonder enough. The pillars are here for now. Tomorrow, in cosmic time, they will be gone. Yet their light remains, etched into our instruments, into our memory, into our collective imagination, and in that way they endure not in the stars, not in the dust, but in us. The pillars of creation stand as emblems of cosmic mystery, but to science they are more than symbols. They are laboratories vast, fragile, and distant, and to unlock their secrets, astronomers wield an arsenal of tools, instruments that stretch the boundaries of human ingenuity. Each is designed not to capture beauty, but to decode it, to transform light into knowledge, and images into truth. The James Webb Space Telescope is the centerpiece of this effort. Suspended at the Lagrange point, balanced between Earth and Sun, Webb peers into the cosmos with instruments crafted for precision beyond anything launched before. Its golden mirrors, each hexagonal and polished to atomic smoothness, gather light in the infrared wavelengths invisible to human eyes, but capable of piercing the veils of dust that cloak stellar nurseries. At the heart of Webb's revelations is UNRCam, the near-infrared camera. It is Webb's sharp eye, sensitive to wavelengths between 0.6 and 5 microns. In this band, cool stars, dust clouds, and nascent protostars reveal themselves with piercing clarity. Through astronomers can map temperature gradients within the pillars, distinguishing cold, collapsing cores from the heated edges where ultraviolet light burns the dust away. Each hue in the image is not artistic flourish, but scientific code red, denoting cooler regions rich in molecular gas. Blue highlighting hotter zones stripped by radiation. By reading this spectrum of heat, IRCam exposes the balance between creation and destruction. The tug of war between gravity pulling inward and starlight pushing outward. On IRCam's sensitivity also allows astronomers to detect protostars too faint for previous telescopes. In Webb's images, they appear as glittering points scattered across the pillars, each no larger in scale than a solar system, yet carrying the weight of future suns, where IRCam excels in the near-infrared. Myria, the mid-infrared instrument extends Webb's reach deeper, between 5 and 28 microns. At these wavelengths, the universe glows with the heat of dust grains, organic molecules, and cooler objects, invisible even to IRCam. MIRI reveals the chemical richness of the pillars. It detects polycyclic aromatic hydrocarbons, complex carbon compounds that cling to dust grains and may seed planets with the building blocks of life. It traces the faint heat of dust sculpted into ridges by shockwaves, each filament recording the violence of stellar winds. And it illuminates the cradles of protostars, still buried in thick veils of gas, their warmth betraying their presence even before nuclear fire has begun. MIRI turns shadows into substance. Where Hubble saw only darkness, MIRI sees the subtle glow of dust itself, revealing the scaffolding from which stars are carved. Beyond images lies a deeper power, spectroscopy, the art of splitting light into its constituent colors. To the untrained eye, a spectrum is a band of colors. To astronomers, it is a language, each line a signature of an element, each shift a measure of motion, temperature, and density. Webb's spectroscopic instruments detect hydrogen, the most abundant element in the pillars, tracing the process of collapse that fuels new stars. They reveal oxygen and sulfur glowing at the edges, markers of gas ionized by ultraviolet light. Carbon compounds, essential to organic chemistry, leave their fingerprints as well, scattered throughout the dust. By analyzing these spectra, astronomers can measure the velocity of gas streaming from protostars in jets that stretch for light years. They can map turbulence within the pillars, tracing eddies and flows stirred by radiation. Even magnetic fields, once invisible, leave subtle imprints in polarized light, revealing how they guide the collapse of clouds into stars. The result is a portrait of creation, not only in shape, but in motion. The pillars are not static. They are alive with flows, shocks, and hidden structures. Spectroscopy transforms them from images into processes, frozen pictures into unfolding stories. Webb is not alone in this quest. On Earth, ground-based telescopes complement its gaze, each tuned to different aspects of the cosmos. In Chile's Atacama Desert, the Atacama Large Millimeter Submillimeter Array, or ALMA, listens to the faint whispers of cold molecules. Its network of 66 antennas spans kilometers, combining their signals into one vast eye. ALMA detects carbon monoxide, ammonia, and other molecules that trace the coldest, densest regions of the pillar's places where stars are gestating in silence. ALMA reveals the hidden scaffolding of gas within the pillars, mapping filaments and knots too faint for infrared eyes. It shows how matter flows into collapsing cores, feeding the growth of protostars. It captures the early chemistry that may one day seed planets with atmospheres and oceans. Nearby, the Very Large Telescope (VLT) of the European Southern Law Observatory uses adaptive optics to sharpen its vision through Earth's atmosphere. The VLT probes the optical and near-infrared spectrum, measuring the velocities of gas with exquisite precision. Its instruments dissect the edges of the pillars, where radiation eats away at the surface, calculating how quickly they are eroding and how long they may survive. Together with Webb, ALMA and VLT weave a tapestry of knowledge, each instrument filling gaps the others cannot. Space and earthwork in concert, stitching together the story of the pillars, from dust to molecules, from turbulence to starlight. Even as Webb reveals wonders, astronomers plan for the next. The Nancy Grace Roman Space Telescope, set to launch later this decade, will survey the cosmos with wide-field infrared vision. Roman will not match Webb's resolution, but its vast field of view will capture star-forming regions in context, showing how the pillars fit within the larger structure of the Eagle Nebula. Concepts for future instruments push ambition further. The Habitable Worlds Observatory, a proposed successor to Hubble and Webb, aims to detect Earth-like planets directly, but its ultraviolet sensitivity will also study star-forming regions in greater depth. Next-generation ground-based observatories, the Extremely Large Telescope in Chile, with a mirror 40 meters across, and the 30-meter telescope planned for Hawaii, promise resolution so sharp they will resolve details within stellar nurseries that today appear blurred. Each of these instruments will turn again to the Eagle Nebula. Each will ask anew, how many stars are forming? How long will the pillars endure? And what secrets still lie hidden in the dust? Behind the tools lie questions, and behind the questions, the human drive to know. Astronomers hope to measure the lifespan of the pillars, estimating how quickly radiation and winds will erode them. They seek to count the number of protostars within. They want to know how turbulence, magnetic fields, and chemistry combine to create stars or to prevent them. One goal is to determine how common such structures are across the galaxy. Are the pillars of creation unique, or are they simply the most picturesque example of a universal process? Another is to understand how many stars, like our Sun, are born in such environments, and whether planets form amid the turbulence of erosion or only in quieter regions. Ultimately, astronomers seek to place humanity in context. The Sun, too, was once a protostar in a collapsing cloud, perhaps in a cluster not unlike the one in the Eagle Nebula. By studying the pillars, they trace echoes of our own beginnings, glimpsing the processes that shaped Earth's star 4.5 billion years ago, beyond their mechanics. These instruments embody something deeper. They are extensions of human senses, designed to hear what eyes cannot see, to translate the silent language of light into knowledge. Alchemy, ALMA, VLT, Romanich, is a form of listening. Each turns the cosmos into signals. Each transforms photons into data, and data into meaning. They are reminders that science is not the opposite of wonder, but its companion. For without tools, beauty remains only surface. With them, beauty becomes understanding. The pillars of creation remind us that creation is fragile, fleeting, and violent. Our instruments remind us that knowledge, too, is fragile, fleeting, and hard-won. Each measurement is a moment, each spectrum a glimpse, each image a window that will one day close. Yet in this fleetingness lies the value. To build tools that can capture the universe in such detail is itself an act of creation, a testament to the same forces that shape stars: patience, persistence, and the transformation of chaos into order. The work of probing the pillars is, in truth, a race against time. The structures may already have been destroyed by supernova shockwaves, their light erased in reality, even as it lingers in the photons reaching Earth. The questions astronomers ask are, thus, not idle curiosities. They are attempts to capture a vanishing moment, to record the architecture of creation before it dissolves. Science, at its heart, is not only the pursuit of knowledge, but the preservation of memory. The pillars of creation may fall, but the data collected by Webb, ALMA, VLT, and those yet to come will endure. They will stand as records of a phenomenon fleeting in cosmic time, but eternal in human understanding. In the end, to probe creation is to probe ourselves. To measure the pillars is to measure the cycle. We are part of the recycling of dust into stars, of stars into planets, of planets into life. The tools we build are mirrors of our longing, amplifiers of our wonder. They do not diminish the beauty of the pillars. They deepen it. The pillars of creation are not permanent, neither are we. But the light we capture, the data we decode, the truths we preserve, these are our way of leaving a trace, a way of saying, we were here and we looked into the birthplace of stars. And in that fleeting moment, we understood. For centuries, humanity looked skyward and saw a myth. Constellations became hunters, gods, and animals. The glow of the Milky Way was imagined as rivers, bridges, and heavenly paths. The night sky was never empty. It was a mirror, reflecting stories back upon those who gazed at it. Today, with instruments like Hubble and Webb, the sky is no longer bound by myth. Yet the impulse remains the same. Even in the precision of science, the cosmos reflects us back to ourselves. The pillars of creation, in their haunting beauty, embody this truth more than almost any image astronomy has ever produced. They are structures of gas and dust, measured in light years, described in terms of ionization fronts and molecular collapse. But they are also metaphors, forms that invite meaning, silhouettes that stir memory. We cannot help but see ourselves in them, though they exist in a realm far removed from our fragile lives. Science gives us the details. It tells us that the pillars are dense clouds resisting erosion, sculpted by ultraviolet light, seeded with protostars. It shows us jets of gas, shock waves, turbulence, and the balance between gravity and radiation. It quantifies their density in particles per cubic centimeter, their length in light years, their erosion rate in kilometers per second. These numbers are the language of physics, and yet, when their images are shown, whether Hubble's iconic 1995 portrait or Webb's infrared revelation. What people feel first is not calculation, but awe. The sight of these columns rising from the nebula is not merely informational. It is emotional. They look like ruins, like cathedrals, like the remnants of something ancient and sacred. Their meaning is not exhausted by their physics, but for the wider world, the pillars of creation are symbols of beginnings. They are the closest thing we have to an image of Genesis matter collapsing into light, dust becoming stars, and in this they reflect something of humanity. We, too, are fragile structures in a hostile environment. We, too, are temporary. Civilizations rise and fall. Languages emerge and vanish. Lives begin and end, all against the backdrop of forces larger than ourselves. Just as radiation strips dust from the pillars, time erodes the works of human hands. Cities crumble, monuments decay, memories fade. What we call permanence is only a slower form of erosion. The contrast between scale makes this reflection all the more poignant. The pillars are 5 light-years tall, towers tens of trillions of kilometers in length. Humanity, by comparison, occupies a thin layer of atmosphere around a single rocky planet orbiting an ordinary star. Our species is a brief flicker in cosmic time, barely visible against the scale of the Milky Way. Yet in our fragility lies a kinship. The pillars themselves are fragile, destined to vanish. Their beauty lies not in their permanence, but in their impermanence. They exist only for a cosmic moment. To see them is to recognize that beauty does not require eternity. It requires timing. It requires presence. The light from the pillars began its journey over 6,000 years ago. By the time it reached Hubble's mirror, civilizations had risen and fallen. Empires had grown and collapsed. Languages had been born and lost. The light we see today is already ancient history, a fossilized moment carried across the abyss of space. In this, the pillars become metaphors of memory. They remind us that all perception is delayed, that the universe we see is not the present but the past. To look at the stars is to look into history, to witness echoes rather than realities. The pillars of creation, frozen in light, may already be gone. Their image endures, but their substance may have dissolved in shock waves long since past, and so they mirror us again. For memory, too, is fragile. What survives of human lives is often not the reality, but the echo, the photograph, the story, the record carried forward. The pillars remind us that time erases substance, but leaves traces. We live, we vanish, but we leave behind the light of what we were. In many traditions, impermanence is seen as a burden. To know that things fade is to feel sorrow. Yet the pillars suggest another view. They are beautiful precisely because they will not last. Their forms are fleeting, sculpted by forces that will eventually erase them. To catch them in this moment is to witness a transient grace. Webb has shown us creation not as myth but as reality, not as an eternal moment but as a fragile process. The stars within the pillars will one day scatter the clouds that birthed them. The towers themselves will crumble, their dust dispersed into the interstellar medium. Future generations of stars may arise from that material, but the pillars will be gone. This impermanence does not diminish their meaning, it deepens it. To look at them is to realize that beauty does not need permanence to matter. It is enough that it exists, even briefly. When Hubble's image was first released, it captured the imagination of millions, not because people suddenly understood the physics of stellar nurseries, but because the image resonated with something deeper. It suggested creation itself, writ large across the sky. It made visible a process that was once invisible, turning myth into matter. For scientists, Webb's image sharpened the details. Protostars counted, turbulence mapped, chemistry revealed. But for the rest of humanity, the meaning was more existential. To see the pillars is to confront scale, to measure our fragility against their enormity, and our brevity against their transience. In that contrast lies humility. Humanity is small. Our planet is one among billions, our lives a flicker against the age of the stars. And yet, in our smallness, we are capable of looking out, of building instruments that capture light from thousands of years ago, of asking questions about creation itself. We may be fragile, but we are aware. The universe, through us, has learned to see itself. The pillars of creation embody a cosmic truth. Creation and destruction are not opposites. They are partners in a dance. Stars form in collapsing clouds, even as radiation strips those clouds away. Supernova scatter matter that will one day coalesce into new stars. Every death is a beginning. Every beginning carries within it the seed of its end. Perhaps the greatest lesson of the pillars is that the universe is not eternal stillness. It is eternal change. It is not a static architecture, but its beauty lies not in permanence, but in motion, in the endless cycles of collapse and birth, erosion and ignition, scattering and gathering. And so the pillars are metaphors not only for time and impermanence, but for the very nature of existence. They tell us that endings are not failures, but conditions of beginnings. That to be transient is not to be meaningless. That to be fragile is not to be empty. In the final measure, the Webb telescope did more than take a picture. It gave humanity a revelation, creation itself caught in the act, not as myth, not as metaphor, but as reality. We see stars forming in their cradles, dust collapsing into light, turbulence sculpting the future. We see the raw mechanics of Genesis, stripped of poetry and yet brimming with it. We see that creation is not serene, but violent, not permanent, but fleeting. And yet, in its fleetingness, it is beautiful. The pillars will vanish. So will we. Both are temporary, both fragile. But in the brief overlap of our existence and theirs, we have seen them. And in seeing them, we have understood something about ourselves. That our meaning does not depend on permanence, but on presence. The pillars of creation are not eternal, but the awe they awaken is. For in their light, humanity has glimpsed the truth of the universe, that everything is dust, that dust becomes light, that light becomes memory, and that memory itself is a kind of creation. Perhaps this is the final thought the pillars leave us with, that the universe is not a place of eternal stillness, but of eternal becoming, an endless dance of creation and destruction, of beauty born in and in that dance, fleeting though we are, we belong.